Today we are going to talk about the vector equation for a plane. Okay. So before we start with the plane, let's talk about a point. Yeah. So we have a point, and when we are talking about a point, it has no dimensions. Yeah. So you can't actually represent it. But then when you speak of a line, yeah. So when you speak of a line, which is a combination of infinite number of points, so you will have infinite number of points in a line. That's what a line is. Yeah. So that's a line. So we have several points, and this line can be represented in a two-dimensional space. In a two-dimensional space, you will have an x coordinate, and then you will have an y coordinate, and that will help you to find the location of the point on the line. Okay, we have talked about that. And then if you consider of a plane, yeah, if you consider a plane, I will draw the plane like this. Okay, a parallelogram, maybe it looks like a parallelogram. So but I want you to imagine in a three-dimensional space. Okay, a plane has infinite number of lines. The plane has infinite number of lines, like this, or maybe in this direction, or maybe even in this direction. We don't know the direction. There are infinite number of possibilities, and a plane is made up of different number of, infinite number of lines. And each of this line, okay, each of this line has infinite number of points, which means a plane has infinite number of points. Okay, so if you consider a three-dimensional space, okay, if you consider a three-dimensional space, you have the x coordinates, and then you have the y coordinates, yeah, and then you have the z coordinates, okay, which are perpendicular to each other. If you consider the origin, it looks like this, okay, and in vector space, we name it as I, and then j, and then k, and this is what we call the origin, 0 comma 0 comma 0. So if you consider in a three-dimensional space, there are infinite number of planes. Okay, there are infinite number of planes, and you can actually imagine this. Okay, you can actually imagine this like a stack of papers. I want you to imagine it like a stack of papers which are stacked one over one. Okay, so it's like this. You can imagine this. Yeah. So this is what's going to help us to understand how we are going to derive the equation for a plane, vector equation for a plane. Okay, so this is the introduction that I wanted to give you. So let's talk about the line again. Okay, let's talk about the line again. So when we wanted to come up with an equation for a given line, what we did was, okay, we selected a point on the line. Okay, we selected a point on the line, and we found the position vector. Let's say this is the origin. Okay, so we found the position vector of that given point. Let's say the point is A. Okay, let's say if the point is A, we can name it as the position vector OA as A. Okay, pretty simple. Yeah, it's pretty simple. Then what we did was we came up with the direction vector of the line. Okay, we needed a direction to talk about the line, and we also found that vector. Okay, and let's say that vector was B. Okay, and these two vectors will help us to find any point on the line. This is what we did when we wanted to find the vector equation of a point on the line. We needed a point on the line and then one direction vector, because in a line, okay, in a line, one direction is enough. Yeah, you need one direction. That's all you need. Okay, one direction, either in this direction or that direction. It's just one direction. Okay, if you put a minus sign, the direction changes, so it doesn't matter. What I want to show is we needed a direction vector and then a position vector of the point on the line. We are going to do the same thing for planes also. If we have an origin here, if we have an origin here, what we need is a point on the plane. Okay, what we need is a point on the plane. It can be any point. The point can be here. Okay, let me delete this first. Okay, let me delete this first. So it can be this point, or it can be this point, or it can be this point, or it can be this point, okay, or this point. But you have to know this is just an imagination, okay? You can't actually draw a plane because a plane is infinite, okay? A plane is infinite. So we need a point on the plane, okay? We need a point on the plane. For for the easiness, let's take this point, okay? So this point will have a position vector. Since it exists in a three-dimensional space, we can actually come up with a position vector for that. Let's say that is A. Okay, let's say that is A. Well, if this is the point A, and we can say the position vector as A. Okay, and if you consider a plane, okay, let's say you have the bird's eye view. Okay, the plane will look like this, like a huge square. Okay, a huge square or huge rectangle, whatever you want to call it. Okay, so in a plane, if you want to come up with a point, okay, if you want to come up with the position of a point, what you can do is you can draw two specific um, you can draw two specific values, okay, in horizontal values and then vertical values to find any point on the plane. Don't you think? It can be this point. Well, then you can give a value for this point and this point, and then it can be this point. You can give a value in y-axis as well as the x-axis. So what you need is two axes. Okay, what you need is two axes to come up with a position for the point. Okay, come up with a position for the point. So that's what we are going to do here also. Okay, that's what we are going to do here also. So if you come back to the example here, so you're going some units, let's say you're going x units in this direction and then y units in this direction. Well, that will take you, okay, that will take you to the point given there. Okay, let me change the color now. Okay, let me change the color now. You're going some units in opposite x direction and you're going some units in the negative y direction. This also represents a point. Okay, this also represents a point. At the same time, this also represents the point. So what you need is two axes. Okay, what you need is two axes. And that's what we are going to use to come up with the vector equation for a plane also. We have a point, okay? It doesn't have to, it can be any point, okay? It can be any point. It doesn't have to be the origin, okay? It can be any point. And then what you need is two specific, okay, vectors, direction vectors actually, okay, parallel to the given plane. That's all you need. Okay, a direction vector may be in this direction or this direction or this direction. The direction doesn't matter. Any direction vector. Okay. And then what you need is another direction vector parallel to the plane, but not to the first direction vector. Okay. So these two direction vectors will help you to move to a specific point. Okay. So what happens is since this is a direction vector, we will use a parametric value. Okay. We say lambda b and we can have mu c. Okay. And for a specific value for a lambda and specific value for mu, you can find out any specific point on this given plane. Okay. And a plane is normally represented with capital phi. Okay. It's like this. So, I mean, you should know this, right? In Greek alphabet, this is simple phi and this is capital phi. Okay. And yeah, we use capital phi to represent plane. Okay, so for a plane, what you need is one point on the plane and then two direction vectors parallel to the plane, but not parallel to each other. Okay, they should not be parallel to each other. What happens is if they are parallel to each other, okay, let's say B and C are parallel to each other, what happens is it just gives us a straight line. That's all. Okay, mu C plus lambda C. That's it. That's what it's gonna happen. Okay, let me explain it to you. If C, okay, I'll use white color. If C is parallel to B, okay, if C is parallel to B, what this means is C is equals to KB. Okay, so here we have lambda b and mu c. Since these two are parallel to each other, what happens is mu c, if you give the equation a plus mu c plus lambda b, okay, it will reduce into a plus mu c. Okay, no, we don't have to write it as mu c. We can replace c with b. Yeah, so it will be mu k b plus lambda b. Since all these are parametric values, okay, I mean, k is not a parametric value, it's a constant value, but still, since you are multiplying with the parametric value, it becomes a parametric value. So all this will represent some t, that t is equals to mu k plus lambda, and it will be a plus tb. And we know this equation is an equation, vector equation for a line. Okay, so that's why we say C should not be parallel to B, but at the same time, C and B should be parallel to the plane. Okay, they should be parallel to the plane. They can't go like this, come out of it. They can't come out of it. Okay, they can't come out of it. Okay, and they are also not perpendicular to the plane. Okay, they are parallel to the plane and they lie on the plane. They are parallel to the plane and they lie on the plane. Okay. If you don't understand this, no worries. Obviously, it's not gonna affect us in any way. But what I want you to do is please go through this again. Okay. There is no harm in going through this again. Okay. So let's come up with the equation. Finally, we'll come up with the equation. So we have okay, so we have a plane. Okay, so we have a plane. Let's say this is the origin O. Okay, and we know a point A, which is on the plane. So we will connect those 2 points, origin and that point A, to find the position vector of A. And then we have two parallel vectors. Yeah, two parallel vectors to the plane. Okay, so these two are the parallel vectors to the plane, and then we can come up with the values. So let's say this is B, and let's say this is C. Okay, and this is pi. The vector equation for pi can be given as, okay, vector equation for pi can be given as R. R is the vector that represents the point on a plane. Okay, any point on the plane. Position vector of any point on the plane. R equals to A plus lambda B plus mu C. Okay, so this is the idea, or this is the main important thing that you should take away from this specific tutorial. Okay, so this is what you need. Okay, it's like the straight line, but here you have two parametric values, two direction vectors. That's all. So you can clearly see here B is not parallel to C. Okay, why 702, and we have 103, and we have -2 over 4. And we know these three values are not equals to each other. So we can say they are not parallel to each other. Okay. Or you can say to go from 4 to -2, you have to multiply by minus half. And if you multiply 2 by minus half, you will get -1. But here we have 7. So these are not parallel to each other. They are asking us to find the plane, the vector equation for the plane phi. Okay. Plane phi is parallel to B and C. So what we have is two direction vectors and then a point. Okay, so we can directly write down phi can be given as R equals to 156 plus lambda 234 plus mu 71 minus 2. Okay, now you can actually use these specific data to come up with other equations for the given plane. Okay, for example, if lambda is equals to 1 and mu is equals to 1, okay, if lambda is equals to 1 and mu is equals to 1, you can come up with a point on the plane. Yeah, you can come up with a point on the plane. So this is the plane. Okay, so this is the plane, and they are saying A is present on the plane 156. Okay, 1, 5, and 6. So this is B, and let's say this is A. I mean, this is C. So we have B here and we have C here. So by using this equation, you can give a value, parametric value, to the equation and come up with a position vector of a point on this plane. Okay. So if lambda is equals to 1, mu is equals to 1, R will be equals to, okay, 1 plus 2 plus 7, 5 plus 3 plus 1, and 6 plus 4 minus 2. Okay, and this will give us 10, 9, and 8. So 10, 9, 8 is a point on the plane. Okay, 10, 9, 8 is a point on the plane. So I can come up with another equation. Phi can be given as R equals to 10, 9, 8 plus Lambda into, instead of 2, 3, 4, I can give 4, 6, and 8 because it is parallel to this vector. And then I can say mu into 42 minus 4. Okay. So if you have any doubts on what I'm doing here, I will attach the link for the video where I teach this for a specific line so that you can build your knowledge through that. Okay. So that's all you have to know about the vector equation of a plane. Thanks for watching the 27th video in our vector series. If you found this explanation of the vectors equation of a plane helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon, stay updated with our latest videos, check out the full playlist to master vectors, and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.